Welcome to 3-2, Simplifying Algebraic Expressions. Today we're going to use the distributive property to simplify algebraic expressions. We learned how to do the distributive property in our previous lesson. Before we begin, we got several terms to learn. And this term, or the word term, is when plus or minuses separate an algebraic expression into parts. You can see in this example 2x plus 8 minus y minus 2. We have four terms. We have 2x, which is separated by a plus sign. We have 8. We have negative y and negative 2. So that makes four terms in this expression. Our next term to learn is coefficient, the numerical part of a term that contains a variable. If we look at the example above, we have two variables. The number in front of x is 2. So that is our coefficient. And our second variable, negative y. In fact, the number in front of there is a 1, so our other coefficient is a negative 1. Alright, we have our next term, like terms. Terms that contain the same variables. Well, you've probably seen this before, but here's an example. This example, once again, is what is the like terms? The like terms are, of course, the same variables, 5y and negative 2y. Doesn't matter what the coefficient is, as long as the variables are the same. Plus 3 and plus 3x are not alike because they don't have the same variables as the y's. Two more terms that are alike are 2x raised to the third power and negative 1.4x to the third power. Notice that they both have the same variable, but they also have the same exponent, and that's very important to know what like terms are like, is that the variable and the exponent must be exactly the same. Once again, the coefficient doesn't play into it whether it's a positive or a negative. The next term is constant, a term without a variable. In this expression, 3x plus 8 plus 14y, we find that the only term without a variable is 8. So the constant is 8. And our last two terms. Simplest form, an algebraic expression that has no like terms and no parentheses. So that means that you combine the like terms and you multiply away the parentheses. Next up is simplifying the expression when you use the distributive property to combine like terms. And that's one way of getting rid of parentheses. We'll do some examples next. In this slide it says identify the terms, like terms, coefficients, and constants in this expression. The expression is 3x minus 4x plus y minus 2. Alright, the first thing we have is terms. The terms are 3x. The subtraction sign makes that a negative 4x. We have a y and a negative 2. We have four terms in this one. Next up we'll do the like terms. Like terms, of course, are terms that have the same variable. In this case, I only see 2. I see 3x and negative 4x. Directions ask for the coefficients. Alright, here are the coefficients. Those are the numbers in front of the variables. So all we do is place the number. And I see that there's a 3 in front of the x, a negative 4 in front of the x again, and there's a 1 in front of that y. The last thing to input in our answer is the constants. Constants are the terms that have no variables whatsoever. There's only one of those in this expression, and that is the negative 2. In this slide, the direction says simplify each expression. I only see one expression. To show work here, really no work to show, but this is good practice, is that we underline, or you could circle, you could put a square or a triangle, square, something like that, that shows which terms are alike. I prefer putting lines underneath for my shorthand. In this case, I can combine the 2 and the 8. 2 plus 8 is 10, and we only need one of the variables. Notice that it's not x squared. That only happens when we're multiplying. Let's try again. Simplify each expression. This expression is a little bit longer. I'm of course going to use underlining to highlight which ones I'm combining first. I do not see any other terms that are alike, so I'm going to go ahead and say to myself 6n plus 2n. I'm going to group those together, then I'll add a 3 to it. 6 plus 2 is 8, 8n plus 3. I am done because 8n and 3 are not alike. Here's another expression, a little bit longer. Notice that the 3x minus 5 minus 8x plus 6 actually has more like terms than you might think. First off, the 3x and the negative 8x are alike. But the constants, and all constants are alike. So I'm going to go ahead and use 2 lines underneath there to show that I'm going to combine those two together. So I'm going to rearrange and group, which is the associative and commutative property. First off, it's the 3x minus 8x. Then I'm going to have the negative 5 plus 6. Alright, for the 3x minus 8, I'm going to change the subtraction into addition, and that means I'm going to make the 8 a negative, because the opposite of positive is negative. That allows me to remember what we've learned in Chapter 2, is that we put unlike signs, we're going to subtract. I get a 5. My 8 is the largest absolute value, and it is negative, so I have a negative 5. And then we take one of the x's. Notice once again we're not squaring it, because that's only for multiplication. We're adding like terms, so the x stays to the first power. Then I'm going to go ahead and look at my constants. I'm going to combine them. I notice that their signs are unalike. I have a negative 5 and a positive 6. So once again I'm going to subtract, and that's 1. And 6 has the largest absolute value. That's why I put it on top. So I'm going to keep it positive, so that's a plus 1. We're finished there. Here in this slide, we're still simplifying each expression, but once again, we're going to use a distributive property, something we haven't used yet. The 3, which is front of the parenthesis, means I'm multiplying. I try to look inside the parentheses if I can combine things, and I notice that my variables are not the same, so they're not like terms. So this is how I get rid of the parentheses, is I use the distributive property. And remember, when I distribute, the 3 goes to both numbers inside the parentheses, not just one. So, now that I'm going to simplify, I have m plus 3 times n, which is 3n. And then I have 3 times 4, which is 12, and that's m. Alright, now we have a new expression. I'm going to look to see if there are like terms. I have an m and another m right here. So I'm going to combine those two together. I have m plus 12m plus 3n. 1 plus 12 is 13m plus 3n. I'm finished here because the variables are not the same. I'm done. Alright, we're going to use what we have just learned and apply it to a word problem. Today we have baseball cards. Suppose you and your brother collect baseball cards. He has 15 more cards in his collection than you have. Write an expression in simplest form that can represent the total number of cards in both collections. So we're just writing an expression, and we're going to make sure that our expression is simplified. Here, let me clarify. You have some cards. Your brother has 15 more. So let's put that in algebraic form. You have some cards. That's x. Well, whatever you have, x, your brother has 15 more. We want to write an expression now that gives us the total of both. So when we total something, we're going to add. So we're going to take your collection, x, and we're going to take your brother's collection, x, yours, plus 15. Now you notice that we have two like terms here. There's a 1 in front of them. So when I combine them, I get 2x. And once again, I'm adding like terms, so there is no exponent to multiply or add to. It still says x to the first power plus 15. We're not solving. All we had to do is simplify, which we did. We combined like terms, and our answer is 2x plus 15.